So now let us try to understand more about ligands. So ligands can be an atom, so it can be an ion or it can be a molecule, but the condition here is that it should be capable of donating a pair of electrons to the central metal atom or the central metal ion. So at least a pair of electrons should be donated by these ligands to the central metal ion or the central metal atom. Now let us talk about the classification of ligands. So there are various types based on the number of atoms that can act as donor atoms in the ligand. So first of all, unidentate, from the name itself it is very clear, uni, that means one. So here these ligands have only one donor atom. So here we have examples H2O, where O is the donor atom. It can donate the pair of electrons towards the central metal ion or the central metal atom. NH3, so here nitrogen is present as a donor atom, and so on. So OH minus, we have so many examples under unidentate ligands. Under unidentate ligands, we have to understand something called as ambidentate ligands. So why I am including these ambidentate ligands under unidentate ligands? Ambidentate ligands, they have two or more donor sites, but still these come under unidentate ligands. What is the reason? Because although they have two or more donor sites, at a time only one atom can be used to donate the pair of electrons. So we have this example. Here we can see that all the atoms in that particular ligand, we have sulfur, carbon and nitrogen. Here also we have nitrogen, carbon, sulfur. But here the atom that is used for forming a coordinate bond with the central metal ion is different. In this case we have sulfur, which is acting as a donor atom. It is forming the coordinate bond with the central metal atom. Here we have nitrogen, which is forming a coordinate bond with the central metal atom. Here, since sulfur is used for forming a coordinate bond with the central metal atom, we call this ligand as thiocyanate. Thio, we call it for sulfur. Here sulfur is used for forming the coordinate bond, so that's why we name this ligand as thiocyanate. Here there is only different arrangement of the atoms, but the atoms are same, right? We have nitrogen, carbon and sulfur. This is called as isothiocyanate ligand. Here nitrogen is used for forming coordinate bond with the central metal atom. Okay, but here we know that there are two donor atoms, sulfur and nitrogen, but at a time only one atom is used for forming the coordinate bond. So that's why I have to include this ambidentate ligands under unidentate ligands. Next is bidentate ligands. Very simple, from the name itself it is very clear, bidentate. So bi means two, so there are two donor atoms. So here we have the example, see, ethylene, because there are two carbon atoms joined together, so ethylene, and there is substitution of course, so that's why ethylene. And whenever there is NH2 group, name it as amine, there are two amino groups, so ethylene diamine. Here there are two nitrogen atoms which can act as the donor atoms. Next is oxalato, or we know that oxalic acid, right? If you remove the H plus ions, the two H plus ions from oxalic acid, we get this oxalato ligand, which can again act as a bidentate ligand. Now let us look into the next classification, that is tridentate ligands. That is, here from the name itself it is very clear, there are three coordinating positions. So here you can see there are two ethylene groups, so diethylene. How many amino groups are there? Three amino groups. So diethylene, triamine. So here you can see there are three N atoms which can act as donor atoms. So of course it is a tridentate ligand. Next, talking about tetradentate ligands. So of course there are four coordinating positions in these ligands. So here you can see there are ethylene groups, CH2, CH2 bonded with each other. So we have 1, 2, 3, three ethylene groups which are present here. So CH2, CH2 here, I hope you know about that. So we have three CH2 groups and four amino groups. So here we know that there are four nitrogen atoms which can act as donor atoms. So this particular ligand comes under tetradentate ligands because there are four nitrogen atoms and each nitrogen can donate a pair of electrons towards the central metal atom. So what is the name of this particular ligand? So we know that there are three ethylene groups and four amino groups. So triethylene tetraamine. So that is the name of this particular ligand. So very simple to remember also. Just looking at the structure of the compound, you can easily remember the name of that particular ligand. Next, we're talking about pentadentate ligand. So we have ethylene group here. So I have written it in expanded form so that it is easy for you to understand. So ethylene group, and here there is amino group, right? But in case of amino group, the nitrogen has been substituted with acetic acid, okay, where you remove the H plus ion. So we have acetate ions. So we have 3 acetate ions which are connected with that of the amino groups here, and overall they are connected to the ethylene groups. So ethylene diamine, how many acetate ions are there? There are 3 acetate ions. So triacetate ion or triacetato ligand. So about nomenclature of the ligand we'll be talking about later, but for now I hope it is clear how to name this. So ethylene diamine triacetato ion. Okay. Now hexadentate, but before that you should know why this is pentadentate, right? There are 5 coordinating positions. So of course here 1, 2, 3, 4 and 5. The nitrogen, 2 nitrogens, it can act as the ligands. It can donate a pair of electrons towards the central metal atom. So 1, 2, 3, 4 and 5. So pentadentate ligand. Next is hexadentate ligand. Very simple to write. So just in this position we need to write one more acetate group. Then we have 4 acetate ions which can act as donor atoms. That is oxygen, it can act as donor atom here. And we also have 2 nitrogen atoms which can act as donor atoms. So of course totally there will be 6. So name of this very simple, because we come across this particular compound many times even in the experiment part in the laboratory. So EDTA is used so many times. So EDTA is the example for hexadentate ligand. So we have the structure ethylene diamine, and the nitrogen is substituted with acetato groups. So we have CH2 COO minus. And I hope it is clear that why we need to write here CH2, because acetate is CH3 COO minus, but here to satisfy the valency of carbon, right? So that's why instead of CH3 we take it as CH2, because the carbon has valency of 4, so that's why the formula will be in this way. And the structure of EDTA is very important, because even in Viva questions they'll be asking you to draw the structure of EDTA. So very simple, if you just remember the name of EDTA, full form of EDTA, ethylene diamine tetraacetate, or here when I'm talking about ligand, as when it is acting as a ligand here, ethylene diamine tetraacetato ligand. So very simple, ethylene is this one, this group, diamine, so we have this particular diamino group, and then tetraacetate. So to the nitrogen you're going to add 2 to each, the acetato groups 2 to each for each nitrogen atom. So we get this structure of ethylene diamine tetraacetate ion or acetato ligand. Okay, I hope it is clear about the classification of ligands.